Need to securely deploy your FastMCP server with authentication, but want to keep credentials out of your code? You'll see the standard pattern for loading authentication, tokens from environment variables, while creating an ASGI-compatible application. The example demonstrates how to conditionally enable bearer token authentication when an environment variable is present, showing the clean separation between your RPC logic and transport security.
Import auth. From FastMCP, import FastMCP. From FastMCP server auth, import bearer token auth. Hash read configuration from environment. Auth token equals OS, environ get, MCP auth token. If auth token. Auth equals bearer token auth, token equals auth token. MCP equals FastMCP. Production server, auth equals auth. LC. MCP equals FastMCP. Production server. App equals MCP. HTTP app.
This demonstrates the environment-based configuration pattern for deploying FastMCP servers with pluggable authentication. The code shows how to create an ASGI-compatible RPC service that conditionally enables bearer token authentication based on environment variables. The distinctive aspect is its minimalist approach to security configuration that maintains clean separation between application logic and authentication concerns. The pattern works by reading authentication credentials from environment variables at runtime, then conditionally wrapping the FastMCP instance with the appropriate authentication provider. The bearer token auth provider handles token validation automatically once configured, while the ASGI application creation via HTTP app makes the service compatible with standard web servers. This approach keeps security configuration external to the codebase while maintaining a consistent interface for tool developers. This approach matters because it solves the fundamental problem of secure service deployment without embedding credentials in code. The environment variable pattern enables seamless transitions between development and production security models, while the ASGI compatibility allows integration with production-grade web servers. The trade-off is minimal configuration that pays off in both security and deployment flexibility, making it ideal for services needing network accessibility with basic authentication requirements. More complex authentication providers follow the same pattern but require additional configuration parameters. Let's break it down line by line.
Import auth.
Imports Python's auth module to access environment variables, implementing the 12-factor app pattern for secure configuration. This specific example reads a bearer token from MCP auth token to authenticate with FastMCP, demonstrating the basic pattern for environment-based authentication that can be extended to other providers. The approach keeps credentials out of code while enabling FastMCP's built-in token validation system.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI-callable tools that handles serialization, validation, and transport. The code demonstrates the basic authentication pattern using environment variables, where MCP auth token configures a simple bearer token auth provider. The conditional logic creates either an authenticated or unauthenticated instance, while MCP, HTTP app, generates an ASGI-compatible application. This pattern supports extension to other auth providers by replacing bearer token auth with alternatives like Auth0 or AuthKit, each configured through their own environment variables following the same 12-factor approach.
From FastMCP server auth, import bearer token auth.
Imports bearer token auth, FastMCP's built-in token authentication handler. This implements the standard authorization header pattern, validating bearer tokens against the configured token from environment variables. The same interface supports other auth providers with identical registration patterns, though this example focuses on simple token-based security.
Hash read configuration from environment. Auth token equals OS, environ get, MCP auth token.
This implements the standard environment variable pattern for bearer token authentication. The MCP auth token variable provides a simple, secure way to configure authentication without hard-coding credentials, following 12-factor app principles. Other authentication providers follow the same pattern, but require different configuration variables and initialization.
If auth token.
This conditional implements environment-based authentication using the 12-factor pattern. When MCP auth token exists, it creates an authenticated FastMCP instance with bearer token auth, otherwise falls back to unauthenticated mode. The pattern cleanly separates auth configuration from transport logic while maintaining ASGI compatibility.
Auth equals bearer token auth. Token equals auth token.
Instantiates bearer token auth with the token from MCP auth token environment variable, implementing standard HTTP bearer authentication. This is FastMCP's basic auth pattern, where environment variables configure the authentication provider, following 12-factor app principles. The same pattern extends to other providers by changing the auth class and relevant environment variables.
MCP equals FastMCP. Production server. Auth equals auth.
Creates an authenticated FastMCP instance using bearer token auth, the simplest provider in FastMCP's pluggable authentication system. The environment variable pattern, MCP auth token, follows 12-factor principles, keeping secrets out of code while enabling automatic token validation on every request. This establishes the foundation for secure RPC. Other providers like auth follow the same pattern, but require additional configuration.
Else.
This else branch creates an unauthenticated FastMCP instance when no MCP auth token exists in environment variables. It demonstrates the basic authentication pattern where bearer tokens are passed via environment variables, following 12-factor app principles. The same pattern extends to other auth providers by swapping the auth class while maintaining identical instance creation.
MCP equals FastMCP. Production server.
This creates a FastMCP client instance for the production server, falling back to unauthenticated access when no auth token exists in the environment. The pattern uses bearer token auth for simple token validation, demonstrating the basic authentication flow that can be extended to other providers like Auth0 or AuthKit with additional configuration. The MCP HTTP app call wraps this configuration in an ASGI-compatible application, automatically validating incoming requests against the configured auth provider.
App equals MCP. HTTP app.
This creates an ASGI application from your FastMCP instance using MCP HTTP app, making it deployable with servers like Uvicorn. The returned app handles HTTP routing to your AI-callable tools while automatically applying the authentication configuration you set earlier, either unauthenticated access or bearer token auth via the MCP auth token environment variable. This pattern keeps transport and auth concerns separate, following FastMCP's pluggable authentication design where different providers, like OAuth or introspection, would follow the same initialization structure. Environment-based authentication. FastMCP2's bearer token pattern demonstrates how production-ready security emerges from simple environment configuration, where a single MCP auth token variable enables authenticated endpoints without code changes. The conditional if auth token block creates either an authenticated or unauthenticated FastMCP instance, while maintaining identical ASGI interface compatibility through MCP. HTTP app. This pattern scales seamlessly from development to production by simply changing environment variables rather than application code.
The token that never appears in code protects every line of code.